minus the derivative of the bottom times the top all over the bottom square. And now, I'm going to do some scratch work. Because there's two places I have to take derivatives, here and here, right? Those are the two places I have to take derivatives. So let me start with that first one. I have u squared minus 2u to the negative 1. So see how I rewrote that top left corner? You agree that that's the same, right? Let's go ahead and take that derivative. So take this, take its derivative, you get 2u plus 2 u to the negative 2. So the negative 1 comes down, but then you subtract 1 from negative 1, that's negative 2. You've got that. Good? That's pretty clean, right? That's not so bad. How about the other one we have to take derivative of? It's u plus 1 over u squared can be rewritten as u to the negative 2 prime. So this one is this one, right? This one is this one. Guys, y'all with me on what I'm doing here? All right, derivative of that? 1 minus 2u to the minus 3. Good. That's it. So this is building pretty quickly upon last class, right? I mean, you have to be able to do the power rule. If you can't do the power rule, you're going to not be able to do this, right? And same is going to be said for the next class. In order to do the next rule, which is called the chain rule, you can't do it unless you know how to do product rule and quotient rule. So it builds very quickly upon itself here. I think I'm ready. Here we go. My derivative is top left corner turns into this. It's in parentheses 2u plus 2u to the negative 2. And then I have u plus, see that one right there? I'm just rewrite it as u to the negative 2 there. Is that all right? Instead of 1 over u squared. Minus the derivative of this one, which we just said is 1 minus 2u to the negative 3. And then times this one, which is u squared minus 2u to the negative 1. I just rewrote that one, just popped the u up there.
That makes it a lot easier.
And then all of this over u plus, I'll stick to the same convention I've been using. I just rewrote that one as this. Okay, any questions? Yeah, I'm going to do this. I'm going to multiply this one out. I'm going to see what it looks like. I'm just curious. That's the raw derivative right there. Okay, here we go. Properties of exponents. Remember, if you multiply x to the n times x to the m, you do what with the? You add, right? So let's remember that. When I go here to here, I get 2u squared. When I go here to here, 2u to the negative 1. Here to here, plus 2u to the negative 1 again. And then here to here, plus 2u to the negative 4. Now, see this minus sign? Very important. Let's figure out what this is right now. All right? What's this first one? 1 times this, u squared. But then I'm going to subtract it. So can I put minus u squared? Okay. So I did that. Now this one. That's going to become negative 2u to the negative 1, but then subtract it. So plus 2u to the negative 1. Here to here, minus 2u to the negative 3 times u squared. It's going to be minus 2u to the negative 1, but then minus, so what is it? Plus 2u negative 1. I almost there? Negative 2 times negative 2, positive 4, but then I'm subtracting. So minus 4 u to the negative 4. Because I'm doing negative 3, I'm adding negative 1, that's negative 4. All of this over u plus u to the negative 2 squared. I'm not messing with that. Any like terms up top? Yeah, lots of them, right? Any of them go away? It'd be real nice if it went away. Some of it, but let's see. How about u squareds? There's 2 of them, and I take away 1 of them. So I should just have 1 u squared left. How about u to the negative 1s? 4 of them? 6 of them? 8 of them? 8 u to the negative 1s? And then u to the negative 4. Negative 2. So I have 2 of them, take away 4 of them. So negative 2 u to the negative 4. And then over this common denominator, u plus u to the negative 2 squared. That's not so bad, right? That doesn't look too bad. No? Maybe so? I'm just showing you the types of algebra, the type of algebra that as Cal 1 students we'd have to become comfortable with. Everything I've done up to this point is, you know, on the table as far as what you should be able to do. I'm going to do something else. I'm going to try and release that guy from the parentheses downstairs. So I'm going to try and square it. Okay? So what I'll do is I'll just write it next to itself. I think you can do that, right? We just did that worse than that. So what would that be? U squared
plus u plus 2 plus u.
Yeah, I'm going to go a little slower. I'm going to go u squared there, right? And then when I do this one and this one, I get what? Plus u to the negative 1. When I do this one and this one, plus u to the negative 1 again, which is going to be 2 of those. So plus 2u to the negative 1. And then finally, plus this and this is u to the negative 4. If you feel like, man, I've got some weaknesses in my arithmetic, and I mean, that's pretty natural in a Cal 1 class to feel weakness here, because you don't usually see this much manipulation in a college algebra course. You don't see this much messing around with it. So, but you have to get, you know, to a point where you build your confidence with it. All right, that is not a bad answer, but I'm going to go even further. Watch this. No, no. Watch me. Again, this is more of just like, do you follow what I'm doing? Do you disagree with what I'm doing? Does it make sense what I'm doing? Is that the same thing? So I just went and took everything back from negative exponents back to positive exponents. Yeah, see, I wouldn't want to. Would you mind taking derivative of that again? It wouldn't be that bad. Relative, I guess. I mean, there's your top, there's your bottom. Could you take the derivative of that? Yeah, it's just power rule, right? Could you take derivative of that? Yeah, so I mean, you could work with this, couldn't you, if you had to take another derivative? Wouldn't be fun, but it'd be a hell of a lot better than working with that, wouldn't it? What we had earlier?
If you don't take the derivative of that again, you have to...
F and G, right? So you would do derivative of the top times the bottom minus derivative of the bottom times the top. It would be a big disaster. Okay, check this out, right here. Again, I'm just asking to see if you agree or disagree. Can I multiply by u to the 4th on top and bottom? Why would I do that?
You're trying to get rid of those u.
I'm going to clear out fractions, aren't I, by doing this? Watch. This times this, u to the 6th, plus this times this, 8 u to the third minus 2, just 2, right? Over u to the 6th Now how about that? Would you mind taking the derivative of that? That's even better, isn't it? Quotient rule on this would be a lot nicer. You following me? Any questions? Okay. With that in mind, though, I'm about to make you upset. Go back to the original function. When we looked at that, we said quotient. I'm just going to do quotient. I'm a robot. How about if I just would have done this first?
That's legal.
That's legal, right? What would that have looked like after I did that? U to the 4th minus 2u over u to the 3rd plus 1. So what I did was I multiplied the top and bottom by the highest power that I saw there to clear out all fractions. Now imagine if I asked you to take the derivative of this, right? Which is what the original problem was asking. What would the derivative of that be? Let's see how fast you can regurgitate this. Derivative of the top times the bottom, right? Minus derivative of the bottom times the top over the bottom squared. What's derivative of the top? 4u cubed minus 2 times the bottom minus derivative of the bottom times top all over bottom squared. I bet you anything that if you clean this up, you're going to get this. In fact, I know you will get the bottom, because if I square that, I'm going to get this. I can just look at it and see that. But I can assure you that if you put all that together, you'll get that. And wasn't that a lot easier? That recognition of something like that comes with time. All right, it's not something that I would expect someone to see right away.
So if we are given a quotient like that and we do have fractions both the numerator and the denominator, we can do that?
Sure, yeah, absolutely. And see, that's what kind of makes this class so difficult, or not difficult, but just there's going to be multiple bridges that get you across the river here. You know, you might choose that bridge, I might choose this bridge. We can all get there. It's just how hard are you going to have to work? And the more comfortable you are with the algebra and the more problems you've done and seen, you can, like when I looked at this, when I first put this up here initially, I put it up here because I wanted you to see how difficult it could be if you follow the rule just like more robotically than if you just think through it a little bit and say, hey, this is a complex fraction. Let me clean it up first. Now that's easier to work with, see? So we want to be thinking. It's not, we don't want to be just like monkey see, monkey do. I do a problem, then you just try and copy that. And if I give you something you haven't seen, you're like, I don't know what to do because he's never shown me that before, you know? You want to be thinking through this. Okay, how are we doing on time? 30 minutes? How are y'all feeling about this? I can feel the joy. I can feel the joy in the room. Got to do your homework, okay? Tonight, for sure, make sure you do your homework. The solutions are up. I worked through those on Monday. I don't know how good the solutions are. I had a bad Monday yesterday. I was just, you'll see if you watch the videos. I almost fainted at the board. I was like, whoa, what's going on? It's weird.
I can't remember what the question was, but you're like, why didn't I get the same answer? And I was like, love the negative.
Oh, I messed up, yeah. I messed up the one on Monday too, but I already fixed it, so. All right, would you like to see the proof of the product rule?
Sure. Sure.
Yes? There's something in it. Who are my math majors? I know that maybe I had, yes, I know I think one, right? Okay, but I think this is more, I don't know. I hate to say I'm going to prove it and this isn't going to be on the test and people just tune me out. Please at least show me the respect of not texting while I'm doing this, all right? Try and pay some attention. Look, or sleeping, thank you. Just let me just remind you that the derivative of f is the limit as h goes to 0 of f of x plus h minus f of x over h. Does everyone agree that is the definition of the derivative of f?
Yeah.
Yep. Okay, and similarly, the derivative of g would be the limit as h goes to 0 of g of x plus h minus g of x all over h.
Yeah.
And if I wanted to, I could put h prime of x, and it's just replace the g with the h, right? Yes? OK. I'm going to try and prove to you the product rule. So here it goes. If I take f and I multiply it times g of x, like that, and I want to know its derivative, I need to show you that it's this, right? F prime g plus g prime f. Now, from college algebra, this is just notation. This means f of x times g of x. That's what the notation means. But then I want its derivative, right? So when you see f next to g, that just means take the f function, multiply the g function. All right. Now the derivative means I need to take a limit as h goes to 0 of this thing with x plus h plugged in first, right? Plug x plus h into this first. So that would be f with x plus h plugged in times g with x plus h plugged in. Minus, now I'm supposed to just plug x into this function. I think what I'll do is I'll write this down over here. Limit h goes to 0. If I said f prime of x was equal to this is the definition. Right, that's the definition of f prime. All I did first was I put x plus h into this function, then I subtracted x into the function. Here my function is actually the whole thing being multiplied. So when I plug x plus h in, I have to plug it into both. There it is. Then I subtract x being plugged into both, which would be f of x times g of x all over h. Does that make sense? Somehow, some way, I've got to show you that this is this. So for my mathematicians and for everyone in here, I'm going to remind you about something you've been doing for a long time that you weren't even, it's kind of second nature to you. Not substitution, this thing. Like we just did this a second ago. On the previous problem, didn't I multiply top and bottom by like u squared? And I was allowed to, u squared over u squared, I was allowed to do that because next to everything there's a times 1, isn't there? And so I can always make that 1 look however I want to make it look. And so multiplying by 1 has always been a useful tool in mathematics. Do you agree? You've used it a lot. But there's an even more advanced tool, better than this, that's required for proofs like this, and mathematicians become very aware of it, and that's realizing that there is a hidden 0 in here. We know that there's a hidden 1 next to everything, but there's also hidden zeros next to everything. So let me try and restate that. If I have an expression and I multiply times 1, I get the same expression, don't I? But I could also say that if I have an expression, I can add nothing to it, duh, and I still have the same thing. I mean, that's like obvious, right? I tell my 7-year-old daughter that, like, what's something plus 0, and she laughs at me. Like, she knows that that's the same thing I started with, right? So, but this is, we've never really used this, right? I mean, you don't find yourself adding zeros to stuff, right? You see yourself multiplying by 1? This is huge. Trust me. This is huge. Hidden 0. So you ready to see my hidden 0? Did you have a question?
Didn't we use that back in trig when we were trying to find the center?
I know that I used the hidden zeros in completing the square. But it depends again on how you're taught completing the square. Some instructors do it a little different. So, all right, so you ready to see my hidden 0, everyone? Here it is. It's not going to be very, very like awesome. You're just going to be like, oh yeah, duh, obviously. That's a 0. But what I can do with it is amazing. Here it comes. I'm going to do it in red. Now, red means wrong, I guess, today. Here it comes. Plus 0. OK, there it is. And then I'm just going to continue writing. Minus f of x, g of x, all over h. That's the same thing, isn't it? That's the same thing. Haven't changed anything. I added a 0, big deal. But now I get to write that 0 however I want. And here's how I'm going to write it. Here it comes. You ready for it? Plus f of x plus h times g of x minus f of x plus h g of x. I'm going off the board. You know what? I'm going to write it up here because I want it to all be on camera. Some things I don't care about not being on camera. This proof is nice enough that it deserves to be on camera. All right, so there it is. And I'll write it in blue so you can see that it is 0. There it is. I still have this. It's bad when I have to take like 3 steps to get the division bar in there. All right, there it is. See my hidden 0? Now, your natural question to me should be, how in the hell would I ever know to use that? And my natural response will be, yeah, I agree with you. Somebody struggled with this for a very long time until they were able to force it to work, okay? So someone had to spend a majority of their lifetime. I'm not talking, I mean, we're talking, when we look at this book, we're talking about thousands of years of thought here, okay? So when I throw this little hidden 0 up here, you have to understand that there are lifetimes behind that 0. Okay, someone spent a lot of time figuring out that this is going to work. So we have to show some appreciation for it. It's not a natural thing. It's not something that you just go, oh yeah, sure, it should just be that. But watch what happens. Do you see what it is though? It's f of x plus h, which matches this, right? But then not g of x plus h, just g of x. Okay, so watch what I'm going to do now.
Well, why not? Why is it just g of x?
Because it's going to work. Because it's going to work. That's the answer. So what I'm going to do now, watch this. I'm going to take this term and this term and put those next to each other. I'm going to take this term and I'm going to put those two next to each other. I'm just going to rearrange it, right? You can rearrange this. Right? Addition is commutative. So let's see, limit h goes to 0. I'm going to have f of x plus h, g of x plus h. I'm going to group that one with this one. So minus f of x plus h, what? G of x. Then the other two I'm grouping are this one plus f of x plus h, g of x. And I'm grouping that one with this one minus f of x, g of x. Y'all still there? Yes? Now, this is all over h, yeah? It's all over h. So there's no problem with me doing this then. That over h and that over h. That's the same. Split a fraction into 2. If they have the same denominator, I can push them back together. I'd have the same thing. Y'all still there? Look at this right here. What in the numerator, what does it have in common? They both have an f of x plus h, don't they? So I can factor that out. Limit h goes to 0. I have f of x plus h, which I've factored out, times, what's still here when I factor that out? G of x plus h minus g of x. That whole thing over h, right? But I could just put the h under here and look at that as being over 1. That's the same? Yeah?
Wouldn't they cancel because it's minus?
What's minus? These aren't the same thing. Right? Plus, now this one, what do these have in common? G of x. I'm going to pull the g of x out, and then what would be left? I don't need parentheses. What would be left if I pulled the g of x out here? F of x plus h minus f of x, right? But I could put all of that over h and say times and that over 1. Do you all agree with this? You sure? Because we're there. Believe it or not, we're there. I would like for h to go to 0. What is the limit as h goes to 0 of this right here? Let h go to 0. No, no. It's f of x. This is going to f of x, right? What is the limit as h goes to 0 of this whole thing.
That's bad.
No. Before I started this whole thing, I wrote two things on the board. I said, do we all agree that f prime of x is by definition limit as h goes to 0 of f of x plus h minus f of x all over h? And everyone said, yes, I agree. And I said, and if I said g prime of x, that would be the limit as h goes to 0 of g of x plus h, right, minus g of x all over h. And I said that would be g prime. Yes? So guess what this is right here? That's g prime of x, isn't it? So f of x times this is g prime of x. Now let h go to 0. H isn't even in that expression. So I have plus g of x. And then what is this if I let h go to 0? F prime of x. That's it. That's amazing, huh? Now, of course, it's written a little different than the way I wrote it. My formula is f prime g plus g prime f, right? So it's like flip the order, but same thing. Now, this one is even more difficult. The hidden 0 in here is a little harder to get. I mean, this one was hard too, but the algebra in that one's a lot harder too. All right, pretty amazing. So now do you believe at least where it comes from? Okay. You have to realize a hidden 0 to make it work. And as a math major, right? Okay, I'm just giving you a heads up. I can prove this without referring to the book because it's that embedded, like it's that wired in. Does that make sense? Like I know what the hidden 0 is for that. And you'll know it one day too. Like it'll just be there. And then same with this one. You'll know what that hidden 0 is because it's so fundamental for these. All right. What do we do? 22? There was a problem. How did y'all do with that? Did y'all try that one from the homework that was the derivative? The 99th derivative of sine x. Did y'all have fun with that? The 99th derivative and the modular arithmetic that I referred to in that problem? Yes? You had to do your homework and maybe watch the video to know what I'm talking about. All right, so if not, then you'll know by the next class what I was talking about. Well, how about this? Because there's a problem in your book out of this section that says, yes?
Yeah, I was going to say, when you were doing the mods on it,
yes.
Wasn't there an easier way? Couldn't you just take the 99 divided by 4? Because you only had 4 options. You had, what was it originally? So cosine x, and it was cosine x. There's only 4 options.
Yeah.
You divided by 4, and you just got that up to 96, and then you took the next 3 after, and it still dropped you in that third category, which was, I think, negative sine x.
I think we're doing the same thing, though. I think the modular arithmetic is doing that. It's just a short way of saying what you're saying, which is you divide by 4 and you look at the remainder.
Yeah.
And that remainder number is which one you choose. So yes, that is exactly what you're doing. But when you write it down, whatever it was, like, 90 mod 4, that means divide 90 by 4 and then tell me what the remainder is. And then that remainder counts which one you're in. So I think we're saying the same thing. But let's try this. How about the 35th derivative of x sine x? Ooh. Ooh. Now, nobody wants to sit here and take 35 derivatives, do you? But let's at least start with the first derivative. And let's call this for the sake of have a name, let's call it y. So y is equal to x sine x. What is the first derivative? So what am I going to use to get that derivative? Product rule, right? Didn't we do this one earlier? We did, right? So it would be the derivative of the first one times the second plus the derivative of the second times the first. Ready? Derivative of the first one is 1 times sine x plus derivative of the second one, cosine x times the first, x cosine x. There's our first derivative. You believe that? Okay. Second derivative. All right. We have two separate terms, right? I can do derivative of each one separately, but that one's a product rule. So when I take derivative of sine, I'm going to get cosine x. And then plus, now here I have a product, don't I? So I have to do derivative of this times this plus derivative of this times this. What's the derivative of this? 1 times that, so that's going to be cosine x plus, now derivative of this, negative sine x, right? But then times this. So negative x sine x. I'm doing this a little fast because this is going to be our last example, and I'm assuming that you could get those if you took your time. You see a pattern? Okay, so what's this going to be? Let me clean it up before I take a derivative. We've got 2 cosine x, right? Minus x sine x. You'll see that? Cosine plus cosines, 2 cosine. Do you have a question? Sure? Third derivative. I'm going to try not to do 35 derivatives here. I'm going to try and find a pattern, but I don't see a pattern clearly yet. All right, when I take the derivative again, I take derivative of this. What's the derivative of this going to be? Negative 2 sine x, right? Negative 2 sine x. And then I'd have to do this one, right? The derivative of this, x sine x. Wait a minute. Wasn't that this? And don't we already know what its derivative is? Right here? So I can have right here minus, now what did we say the derivative of that was? It's this, right? So sine x plus x cosine x. Did y'all see what happened there? Y'all have gotten real quiet. More quiet than usual. Are you following me or not? Okay, yes.
When you take the next derivative, you can just leave that negative alone and just do the derivative.
Are you saying the next one, like you ready for the fourth one? Is that what you're asking?
Well, actually, you could take away those parentheses, couldn't you?
I would like to, because see that sine x? It can join up with those. So I'm going to simplify one more level before I do another derivative. What would my next line be? Negative 3 sine x minus x cosine x. That's right. So that's my third derivative. Ready for the fourth? Am I going to write 4 prime marks? I guess I could, but that's the proper notation. A 4 in parentheses. Now when I take derivative of this first term, I'm going to get negative 3 cosine x, and then minus, in parentheses, did I ever take the derivative of x cosine x? Yes. I did, right? Where was it? It was that right there, right? This piece right here? I did the derivative of that earlier, and it turned out to be these two, right? Just like that. Those two. So I'm going to say negative 3 cosine x minus this, cosine x minus x sine x. And I can put this together and drop parentheses, right? So what would I have?
Negative 4 cosine x.
Negative 4 cosine x
Minus x sine x.
Plus x sine x. Ah, x sine x again. It's back, right? Maybe we'll do another one. Just so we can, you already have the pattern? You already see it?
Yeah, it's gotta be.
Okay, let me see. Let's try, verify. The next time I take derivative of this, it's going to be no, positive.
5 sin x.
Well, let me do the whole thing and then I'll put it together. This will be what? 4 sine x, right? Because derivative of cosine is negative sine. Negative 4 comes for the ride. Negative, negative, positive. Then the derivative of x sine x is, we did that already, sine x plus x cosine x. And when I combine these together, 5 sine x plus x cosine x. Okay, maybe that's enough to see the pattern. All right, what is the pattern? You said you saw it. You want to tell me what it is? Here's what you have to be able to tell me though. What's the nth derivative? You have to be able to give me a general. No, not the 35th one, the nth one. So you need to give me a formula for any n. That would be finding a general pattern. I know you can count your way to 35, but I want to be able to give any number and you give me an answer. So can we back up? Just kind of go through this a little slower. Look at, when we had the first derivative, right? This is a 1. Our answer was we had 1 sine, right? And we had this x cosine x. When do we see x cosine x again? In the third derivative, right? See it right here in the third derivative? So in the third derivative, we see x cosine x again, but this time what? It's subtracted, correct? And then what about this number here? It's negative also, but it's a negative 3. Doesn't that negative 3 match up with 3 up here? So I could maybe just write it this way. See, I'm trying to come up with a pattern. So I'm going to write it like this now. Negative 3 sine x plus x cosine x. Is that the same thing? Yes? So somehow, the 3 is telling me the number in front of sine. This will always be x cosine x. As long as it's odd, it looks like that might happen. But we also have that this was negative and this one was positive. I'll deal with that in a second. Let me go to the 5th one and see if it follows the pattern. I'm on the 5th one, right? I should have 5 in front of sine x. I should have the x cosine x appear. This one's positive though. So it started out what? Positive, then it went negative on the third one, and then it went positive again. So let's guess, what should the 7th one be? Negative 7, put it in parentheses. Sine x, come on. Negative 7 sine x plus x cosine x. Seems reasonable. What about the 9th one? Positive 9 sine x plus x cosine. I factored, so it should stay plus the whole time, right? It was plus here, as long as I pull that negative all the way out. So it looks like I've got kind of a pattern for odds, kind of. I do have a switching of signs that I need to deal with. What about for the evens? What about for the evens? 2, right? I'm going to have, instead of sine, I have what? Cosine, and then minus x sine x. What about for the 4th one? Minus, but this time it's plus, so I could do another thing where I factor, right? All right, I'm going to offer this as a bonus. Due next class. I don't expect everyone to get this. In fact, I don't know if anyone will. I want a general formula for n. The reason why it's bonus is because I haven't shown you anything like this, all right? Yes.
And this reminds me back in algebra where it's y to the n minus 1, close the parentheses, and then it's like a, and then there's other numbers.
Well, look, it should be something like this, all right? I'll give you a hint. It's going to be something like this. It's going to be either like n, what do we have here? It's like n sine x plus x cosine x, as long as n is what? Look, right here. Odd, but you also have to take into account the alternating of the sign. That's the trickiest part of the whole thing. because it's going to switch signs. So I'm curious how you'll deal with that. The other one follows similar pattern. It's for your own enjoyment. All right? Now, we could answer the question about the 35th power by just kind of reasoning our way to 35 now. But I'm curious if we can come up with a formula for n. All right, that wraps it up for today. So make sure you do your homework. That's priority. Don't be spending, the rest of the next 48 hours on this, all right? Do your homework for product and quotient rule. You must be able to do product and quotient rule to be able to do chain rule, which is the next one, the big daddy. Enjoy the rest of your day.